About the classifications of shapes and the classifications of numbers. We classify shapes, okay, and then we classify numbers. So 4, 8, I can't remember which one's which. We'll start with classification of shapes.
That's 4, 9.
Oh, okay. Well, we're doing 4, 9 first because we're doing classification of shapes. Okay. So we can have, I'm going to start kind of with now I'm going to start broader. Okay. There are polygons. This might not all be on your thing, but a polygon is a closed figure that has straight lines as edges, okay? So a polygon is a closed figure.
I'm sorry, it's 4, 8.
Okay. Thank you. It's a closed figure with straight lines as sides. Okay. So, an example of a polygon, and they're classified, how they're classified is by the number of sides. Yep. Okay. So the smallest one is a triangle. Tri actually means three angles. Don't ask me why we have triangle, and then the next one is called a quadrilateral. This actually means the word side, and quad, if you think about it, quad, it has 4 tires, so it's 4-sided. So we name them kind of weird. The first one is 3 angles. The next one is 4 sides. Okay, it's not consistent at all. Okay, then we go to so that's a quadrilateral. It has 4 sides. Doesn't matter if there's different types of quadrilaterals. We'll classify them in a minute. Okay, so 3 sides, 3 angles. 4 sides, 4 angles. Okay, so there's definitely a tie there. Okay, a 5-sided one, I can't do very good, but a 5-side, does anybody know what a 5-side is called? The pentagon. The pentagon, which we actually have a pentagon in Washington, D.C. It is built with 5 sides. The building itself does have 5 sides to it, so it's called a pentagon. Penta means 5, gon means it's part of a polygon. The gon part here is really, it talks about angles. It's some sort of abbreviation for angles, but that's what you're looking at. Yes?
Just the one government thing or whatever that's really high tech or whatever they call it, like something like pentagon or something.
That is the
Is that the
pentagon.
same one?
Yeah, that is. Okay. The next one we see, which I can draw a little better but not too good, is hexagon. So from pentagon on, they end with gon. Okay. This is 6 sides. Hexa means 6. There's a septagon, an octagon, a nanogon, nonogon, I'm not sure how you call that, and a decagon. I don't know what 11 is, but I do know that dodecagon is 12. 10, 9, I might have spelled this one wrong, 8, and 7. So that's how so there is classifications for polygons. They have different ways that they're named. Okay. The first two are kind of the odd ones. It's not called a trigon or a quadron. They actually use the word angles and lateral, which means sides on those. So that's basically how we classify polygons. Then we go into classifying the triangle and the quadrilateral. That's really as much as we really classify up as we're going through.
Wait, is there no 11?
I don't know what it is. That's why I said I don't know. I can't tell you that off the top of my head. I'm sure there is, but I don't know.
Is it a quintagon?
I don't think quint. Quint means 5 also, so I'm not sure what it is. Okay. So now we're going to start to qualify or classify triangles. Okay. We can classify triangles by their sides or by their angles. Okay. So first by sides. If sides are equal, all sides are equal, well, that is called an equilateral triangle. That's a symbol for triangle. Again, equal side. Lateral means side. Okay? If anybody plays football or watches football and they know what a lateral pass is, it's off to the side. So that's what the word lateral means, is to the side. Okay? So equal sides, then there's 2 equal sides, that's an isosceles triangle. So this has 3 equal sides, this has 2 equal sides. And if there are no equal sides, it's called a scalene triangle. Okay, that's how we classify them by number of sides. So a triangle, when you look at a triangle, it's either equilateral, isosceles, or scalene. Okay, that's being by the number of equal sides. Yes.
Is there any type of object in the world that only has 2 sides and like nothing in between?
So can you make something like that?
If
A polygon, would it be closed? There you go.
If the atlas goes around.
Would that be, can I close that without a third side? No, I can never make a 2-sided. That's why we start out with triangles, because it's the first one we can actually make a shape with. 1 does not make a shape either, all by itself.
Technically 1 would be a 2, because it'd be one face.
Well, this is a line. We'll go back into these. These are angles. They're actually given special names, but they're not polygons, because they're not closed.
I'm thinking more of like a 3D rectangle when you squish the sides.
Well, 3D is something different.
But then if you squish it, then you have nothing. But there can never be something just skinny enough to be like other than atoms, but atoms is something.
Yes. So right now we classify them. When they are closed figures, they are called polygons, but they have to start at a triangle. You can't start anywhere else. Okay? So this is the number of sides equal. We also classify them by angles. So they're called acute triangles. And that's where all angles are less than 90 degrees. So that's all of the angles are less. Okay. The next one's a right angle or right triangle. Right triangle is when you have exactly one 90-degree angle. Okay. And a obtuse triangle is when you have exactly one angle greater than 90 degrees. So here, all the angles are less than 90. Here, it's only one angle is 90 and one angle is greater than 90 in these two. Because your other angles it has to add up to 180, so you can't have two right triangles or two obtuse triangles or two obtuse angles inside of those triangles. So you can classify everything as in a triangle as by sides or by angles, depending on how they look. And every triangle will have an angle and a triangle classification. I mean, an angle and a side classification. Okay, so all triangles will have two classifications they fit into. Okay. So that's really how we do classify triangles, is by their angles and by their sides, two different sets of names. Are you not
I
done?
just have to write down
Okay,
angle.
I'll let that stay up there. I'll start at the top. I don't know which one we just did, so then we'll just throw it up.
3.8, definitely.
4 points, wasn't it?
No, 4.8.
Yeah, it is 14.
Screwed it all up. Oh, man.
Well, she is recording, so you can just go back.
That's true. I am recording.
I want to share this with
I don't care if you say it.
One time there was a break and the camera was on and then grandson someone.
Yeah, I've had some funny recordings, let me tell you. It's when I hit things I'm not supposed to, or they fall over, or I have all sorts of things.
Angle is that
Greater than 90 degrees.
Yours is so much more neater than
Okay, quadrilateral, we talked about, what does that mean? And quadrilateral has how many sides?
Are we on 4.8 now? Or 9?
Nope, we're still in 4.8.
4 sides.
It's 4 sides. Remember, this is 4 sides. So there are classifications of 4-sided figures. Okay, so we start with the most broad classification. That's called a trapezoid. Besides quadrilateral, that's any 4-sided figure. Inside the quadrilaterals, we have trapezoids. Trapezoids have one pair of parallel sides. So a picture of that would basically be something like this, where these sides are parallel, or it could look like this. These sides are parallel. So the top and the bottom are usually the ones we write as parallel, but they don't have to be because we could turn it. Okay. But usually when we draw a trapezoid, we put the parallel lines as the top and the bottom of the figure. It doesn't have to be drawn that way, but that's usually how we do it. Okay. There's a special type of trapezoid. It's called an isosceles trapezoid. And it's very much like an isosceles triangle. It has 2 sides that are equal. So it's the non-parallel sides are the same length. Okay, so if I were to draw a picture of it, it's when, I don't know if I can do that very well, but those are the same length. So the non-parallel sides are the same length. These are our parallel sides, and then the non-parallel sides are the same length. Okay, so that's called a trapezoid. Okay. Inside the trapezoids, we actually can find something different also. It's not an isosceles trapezoid, but we can also find what are called parallelograms. That's not how you spell parallel. That's what I'm doing. Parallelograms. And these have opposite sides are parallel. Okay. A picture of this would be basically something like that. This side's equal to that, that side's equal to that. They are parallel to each other. And what ends up being is the opposite sides are actually the same length too. They're not only parallel, but they are the same length.
Slanted square.
It's a slanted square, but a square actually turns out to be a parallelogram. It fits inside that category. So basically you start out with the trapezoid, and in the trapezoid you have an isosceles trapezoid. That's one classification, and then you can also have a parallelogram. That's another classification. Okay, so these are both within trapezoids. Trapezoids, though, can be any picture. They don't have to be isosceles or parallelograms. They can be any that just has one pair. Yes.
The parallelogram, like, is it possible to have, like, when it's slanted, is every side the same? Like,
No, a parallelogram is not like that, but when it is one with all that, so when it is one that's all the same, but it's still slanted,
like
okay.
6 plus 6 plus 6 plus 6.
Yeah. It's called a rhombus,
Oh.
okay? So there's this special category over here that's called a rhombus, and that's when it's a parallelogram with equal sides. It doesn't necessarily have 90-degree angles though, okay? So this is a parallelogram. With all equal sides. Okay. Now, within parallelograms, there's the rhombus. There's the rhombus. We're going to call that section 2, okay, of that. The first one inside of a parallelogram is a rectangle. So a rectangle is a parallelogram, but it has 90-degree angles. All angles are 90 degrees, okay? So this is a parallelogram. With all 90-degree angles. Remember, there's 4 angles. Inside the rectangle, so now we're kind of going inside the rectangle, so I'm going to call it A, we have squares.
Aren't all squares rectangles? but
Yep.
Not all rectangles are squares.
That's correct. So squares are rectangles with equal sides. And what's kind of interesting is squares also fit in the rhombus category. They are a rhombus. Oops, I'll put squares here again. They can also be a rhombus with all 90-degree angles. So a square kind of fits within both the rectangle category and the rhombus category because it's just more specified. So it fits in both of those. So you start with this big group of quadrilaterals, okay? You come down, you have trapezoids, which are a more specific type of quadrilateral. Then you go into the trapezoids and you have a special category called the isosceles trapezoid, but it doesn't really have any classifications under it, okay? You go into another section that's called parallelograms, and in that we have both rectangles and rhombuses, okay? And then rectangles, the squares fit into both categories, the rectangle and the rhombus category, because they are they're rhombuses because they have equal sides, but they also have the 90-degree angles, which goes with the rectangle, okay? So that's basically your classifications of quadrilaterals, okay? All the different types of quadrilaterals. When you go into geometry, you start studying these more in depth, you find out different things about the midpoints of these when you connect them, about the angles and which ones are equal, which diagonals, which we haven't really talked about, but diagonals are connecting the vertices, which ones are equal in size, which ones make perpendicular shapes, all that kind of stuff. So you go into a lot more detail about these classifications. And that's basically part of what geometry is going into more detail and what you can find out about these. Okay, questions on, so we did triangles and quadrilaterals. We are not going to pentagons or classifying any of those any farther. There aren't really, what there are is in polygons, there's called regular polygons. Regular polygons are when all sides of that shape are the same length. So if you have a square, that is a regular quadrilateral, okay, because all sides are the same length. Or if you have a rhombus, that is actually a regular because it has actually got all sides the same length. Okay. Okay, next. Actually, no, in a regular, it has to have all angles the same, so it's only a square. Sorry about that, I forgot about that. So that's the classifications, and I didn't really use the Venn diagrams there to show that. It's just kind of easier. Okay. What we're going to show now is the classification of numbers.
Should I write on the back of the page or should I hold everything?
You can write wherever you want, as long as you start something new, or start, classification of numbers. They don't classify the same, okay? We are going to start with the biggest classification that we know right now, okay? The biggest classification we have right now is real numbers. And I'm saying, okay, that brings a question to me. If that's our biggest classification we know now, is there another set of numbers? There is. There's ones called imaginary numbers. Now you think math is hard? Wait till you get to imaginary numbers. How do I imagine imaginary number? That's for later when you get older.
So, wait, like literally imagine it or like?
There's actually a form, and I'll define it when you get older. So it's used a lot in electronics and electricity and in computers and all that kind of stuff. So that's where it's used a lot.
What grade do you, like, if you learn this in school, what grade do you?
You start learning that in algebra and advanced algebra. A lot more in advanced, okay? So real numbers are basically all numbers that are rational and irrational. Now, I know you probably don't know what that means, but they're all rational and irrational. Okay, so basically, if I were to draw a diagram, here's my real numbers. And this splits into two. On this side, we have irrational numbers. And on this side, we have rational numbers. Now, that doesn't mean that one of them is always, irrational, they cry on everything, they don't make any sense, and the other the other numbers are always make sense. That's not true, okay? How we define rational numbers. Rational numbers are anything that can be written as a fraction. Now, I'll give you where rational comes from. It's really coming from ratio. A ratio is just a type of fraction. Okay, so this really means fraction. That's the ratio, but ratio is really a fraction. Okay? That's anything that can be written as a fraction. When we write numbers as fractions, there are two things they will do if we do the division of the fraction. So if you divide the fraction, you will have two things happen. One, it either terminates or it stops. Or two, it repeats at some point. And it repeats infinitely. It starts repeating. Okay? Let's look at some examples. The number 4, which can be written as 4 over 1. If I do 4 divided by 1, that is a fraction. It stops at 4. So it stops. Okay? That's an example. If I do -2 over 4, that's really the same as -1 over 2, which if I do that division, is going to be the same as -0.5. So it stops. It doesn't start repeating, it just stops. Okay? So fractions, when you divide them, either stop or they start repeating. So if I said 4/3, that's the same as 1.3 repeating. The 3 repeats forever. So it starts repeating. That's what's a repeating fraction. Okay? If you do things like 1/7, I don't remember I shouldn't do that one. I'll do 1/9. I think that's 0.11111. I'm pretty sure. Let me make sure. Yes, it is. 0.1 repeating. I do 1/9, just 0.1 repeating. Okay. So, rational numbers are anything that can be written as a fraction, which means that when I do the division, the decimal itself either stops or it repeats. The reason that's important is because how I define irrational numbers never stop and they never repeat.
So like pi?
Yes. An example, the most famous one is pi, because pi never stops. We've never found the exact number of the circumference divided by the diameter. Okay, that is what pi is. The more accurate we draw stuff, the more we find that it does not ever repeat. And it does not stop. Okay. Another example is called E. E is also a number. It's 2.71 something. It's called the natural number. It never stops and it never repeats. Okay. Any square root that cannot be simplified, like the square root of 2, the square root of 7, the square root of 10, the square root of 11. Any of those, there's not a perfect square to them. I cannot simplify it because I can't find the exact number that multiplies to give me 10 or that multiplies to give me 11. Okay? Those, if you put them in your calculator, if you have a calculator right now, put in the square root of 2 and see what you get. Okay, you have a calculator? Zico, have a calculator? No? There's one in there, yeah. Put in and see what you get with the square root of 2.
1.41.
Does it keep going? Yes, it keeps going. It will actually never stop and it will never repeat if I kept going past what your calculator can go.
It says the square root of 2 is 1.0000000.
That doesn't sound right. It should be 1.4 something. Take 2 square roots or square root 2. Do you know what square root is, Cindy? Okay.
Okay, so 1.414213.
It doesn't stop and it doesn't repeat. It keeps going. Okay. Okay. You try the square root of 7.
There it was.
Try square root of 7. See what you get. Try the square root of 7.
2.645751
Goes clear out to the end of your calculator, but in effect, that's all they can write down because they don't have any more space. But it would go on forever and ever and ever. So all of these are irrational numbers. We don't use irrational as much, but we do use them in triangles. We use a lot of irrational numbers in triangles. We use a lot of pi numbers in circles. So some of our geometric shapes have irrational numbers dealing with them. Okay. Well, inside the irrationals, we break it down, or the rationals. The irrationals are just a group. We don't break them down any farther. Okay. Inside the rationals, we find other numbers. The biggest group is going to be the integers. Does anybody know what integers mean? When I refer to
A
integers,
whole number
and it's,
and negative numbers.
yes, it's whole number and it's opposite. So it's the whole numbers and opposites. Okay, so that means it'd be -1 or 1, 2 and -2, etc. I'm gonna move these in a minute, okay? Within the integers is the whole numbers, which are 0, 1, 2, 3, 4, etc. This is the opposite, so the integers has those numbers plus the opposites, which are 1, 3, 4, etc. There's not a -0 though, okay? So so whole numbers are with integers are within rational numbers. Or you could say fractional numbers if you wanted to. If you called these fractional, I would say that's fine. Because that's really what they are. Ratio means fraction. So if you say fractional numbers instead of ratio numbers, rational numbers, that's fine with me. Okay. I just want you to know how we normally start teaching you is we start teaching you, Jonathan, we start teaching you with whole numbers. Think back to when you were younger. You only worked with these nice little positive numbers, right? You didn't work with fractions. You started with adding 2 + 2 + 4 + 7, those numbers, okay? Then this is what's kind of weird. We don't go from whole numbers to integers, which I think is kind of strange. We go from whole numbers out to positive rational numbers and only use positive rational numbers. So we teach you how to do fractions with the positives. Then we go back to integers, and then we go back to all rational numbers, which include positive and negative fractions. Okay, so there's a difference in that. Okay. So these are the main categories of numbers that you will see that we work with, especially now that we're in algebra, we're going to deal with all of these. Okay. Once you get farther in algebra, you add imaginary numbers and complex numbers. So don't you love this? Mathematicians thought, oh, we have all the numbers represented, we'll call them real numbers. Then they realized they didn't have all the real number or all the numbers represented, so they called them imaginary and they called them complex. So that goes on farther. Okay. So this is basically some of the classifications. They're going to have you work today with just figuring out what things are classified what. Are rectangles always parallelograms, or are parallelograms always rectangles? That kind of thing. So you can look at your definitions to see which one is in which category or what's always true. Okay. So go ahead and take a 10-minute break. When you come back, I will have this all ready for you to